welcome. I am one of the foreign managers here at Cosmic Girls. I am located in Boston, but I am originally from Mexico. I have lived in Guatemala and Brazil before coming to the US for college. And I love the work that Cosmic Girls is doing and breaking down barriers for girls and women in the space industry. I'll pass it now to Mindy to introduce herself.
Yeah, I'm just want to say as the girls are coming in, hi everyone. I see we're getting more girls coming into the webinar. It's very exciting. I'm Mindy Howard, the founder and CEO of Cosmic Girls. Happy to see you all here. I know we have a very exciting talk today, and Carla's going to introduce Madison in a second. But I think we have enough girls already to start. We're kind of right on time. So Carla, take it away. Please introduce Madison.
Yeah, for sure. Of course. Thanks, Mindy. Our speaker today is Madison C. Feehan, founder and CEO of Space Copy, the first company creating a multi-purpose interplanetary manufacturing and material testing system, combining spectral data analysis, AI, and 3D printing into one mechanism. Madison has a background in advanced lunar instrument development and early-stage innovations for NASA's planetary science, heliophysics, and astrophysics division, and is channeling her expertise into deep tech development for in situ resource utilization, or ISRU for short, with entrepreneurship. She holds a Harvard Business School certification in entrepreneurship and innovation and has a commitment to shaping foreign policy for small businesses in STEM through volunteer work with consortiums including the United Nations, Lifeboat Foundation, and National Small Business Association. We encourage you to ask questions and take advantage of this opportunity. I'll be checking the chat and making sure there's no unanswered questions, but Madison, please take it away.
Thank you so much, Carla,
Yeah.
Mindy. Appreciate it. And good morning, everybody. Really glad to be here today. And I love when it is a small and intimately focused audience too, because I feel like you get the best opportunity to really outreach to people. So I'm glad for the people that took the time out of your busy schedules to be here today. And glad that we're recording this too, so that we can get the word out to an even broader audience. But I just want to say thank you so very much for inviting me to be here today. I'm going to kick it off with a presentation. We can go to Q&A at the end. If you have anything in the meantime, encourage you to put it in the chat box. But my bio is self-explanatory. I will get into a little bit more of that as we kind of move through the presentation, but let's get started. And we're going to talk about everything from 3D printing in space to how young women can have careers in space, what your career options look like, some of the finer work that we're doing at Space Copy and the rest of our team. So with that, let me kick off a screen share. And I will just bump that into full screen mode. And would somebody let me know when all the slides are visible?
They are good.
All right, perfect. Well, in that case, good morning again, and welcome to this presentation, both on Space Copy and the power of 3D printing in space, but also in tandem, what it's like to be a young early career professional who is a female working in this domain, and how we can boost more awareness for women in STEM. So again, kind of just kicking it off with my background. My traditional education is not in engineering. I pursued an education in international business and commerce. I also worked for NASA for about 6 years. So I was working in heliophysics, so studying the sun, astrophysics, planetary science, but most of my technical background had to do with dual use technology. So things that benefited life on Earth just as much as life in space. And aside from that, I love to do a lot of volunteer work, mentorship, everything from the United Nations to being a student mentor for Concordia University in Montreal. It is my goal to be able to share with more people what it takes to have careers in space. And it is not as challenging as one might think to break into the industry. What the challenge is sustaining yourself and growing and elevating the other people around you. Now, I want everybody to kind of walk back in time a little bit. We were coming off of International Moon Day this past weekend, which celebrated the anniversary of the first human spaceflight landing, July 20th, 1969. What if It is 1969 again. Let's walk that thought backwards. We're on the final lunar frontier. Apollo 11 astronauts are preparing to step foot on the lunar surface for the first time in recorded human history. I know that when we look back on memories like this, it's poignant. It creates such a narrative for why we continue to be in this industry today. But just thinking about that in a broader context, there was a lot of things that could have gone wrong when sending humans to space for the first time for a lunar mission. And we were really fortunate considering that technology wasn't as advanced as it is today. What if something had broke on that lander? What if an electronic control had become unresponsive? There is a myriad of different things that could have happened between transport, landing, and the return mission that could have impacted the entire integrity of a space-based mission. The question becomes, what do you do? If you are working in today's age of technology, the most radical and even logical thing that you would do is you would just manufacture a replacement part when something breaks down in space. Now, this is part of the technology that we bring to light with Space Copy, and I'm going to spend about 10 minutes just walking through what is 3D printing, what is in-space manufacturing, and what are we building. So if you're already familiar with 3D printing, this is going to be a rather rudimentary conversation, but I'm going to elevate it by talking a little bit more about microgravity effects and space-based applications. So additive manufacturing or 3D printing, they're synonymous terms. I'll use them interchangeably. 3D printing is essentially the art of creating three-dimensional objects from a digital file using feedstock, which is a raw material generally composed of plastics or metals. It is not solely plastics and metals, but it is commonly materials like this. It is implemented in many, many different fields, not just aerospace, also defense, also automotives, medical industry, even the fashion industry has taken a really broad approach to 3D printing in commercial contexts. So it can be used in everyday consumer life. You can have a mini 3D printer in your house that is printing a tool or a repair part or a hobby piece, or you can commercialize this, use large size industrial printers for commercial-based applications like building precise geometries on car parts or building rocket propulsion systems. I know of a fantastic company that's also up in Canada. They're called Reaction Dynamics. They are 3D printing a whole bunch of different rocketry components, and I think it's absolutely radical to see people using 3D printing in this kind of context. I'm going to talk about two specific types of 3D printing. This is where we kind of get into the weeds of it. I'm going to talk about extrusion printing, and I'm going to talk about another type which is more kind of ornate and complicated, which is called laser powder bed fusion. So breaking it down, extrusion technology, or FDM, fused deposition modeling, is the type of 3D printing that is most commonly recognized around the globe. It uses generally a lot of thermoplastics, but you can use anything from polymers, composites, carbon fibers, metals, ceramics. There's a whole bunch of different things that you can incorporate. But generally speaking, I like to think of extrusion technology as like icing a cake. You have your pipe piece, you have your slurry of filament, and you are squeezing the nozzle to build upwards to create a 3D object based on a digital file. The FDM or fused deposition modeling technology is extremely cost effective. It's used widely across multiple different industries. It has that layer by layer deposition that allows you to create very solid 3D objects, but it's also relatively fast and relatively versatile. There is not a lot of training or calibration that goes into knowing how it operates. And generally speaking, as the platform itself is lowering and as you're building upwards, you can have thickness of layers anywhere from zero point 0.1 to 0.3 millimeters. If you want to be really bold, you want to use this for large scale manufacturing, like construction and housing, you could have layers that are 4 to 6 millimeters per layer. That allows you to rapidly build up things like housing. Um, but in a general sense, regardless of how your layering process works or what size and scale you're doing this on, material is extruded through a nozzle onto a build platform, and that material solidifies rapidly and bonds to those previous layers. So it's not the cleanest of processes. There's things that can always go wrong. There's some delamination that's pretty common, is where air bubbles and process parameters aren't calibrated correctly and it just gets stuck. That can lead to things like nozzle clogs and overall print failure. It happens. That's just a reality of working with extrusion 3D printing, but you can take a lot of due care into creating rapid, medium to larger scale structures from FDM 3D printing in a relatively uniform manner. And I'm going to dive into that a little bit more further. But first, let me talk about the other type of 3D printing that is laser powder bed fusion, or the sub-variant, because there are so many different sub-variants. Selective laser melting, or SLM, is a particular one that we'll be featuring today. Um, any kind of laser powder bed fusion works in similar ways, but specifically for SLM, you're talking about using a bed of powder. So that could be metal, that could be ceramic, that could be pretty much anything you want it to be. And then you're using a high energy laser to essentially carve out the shapes of what you're trying to build. And then you have a recoater blade that works similarly to your windshield wiper of your car that is passing through and wiping that finished part and passing a new layer of powder over top of it. And then that melting process with the laser just continues over itself again. It's extremely energy consuming, it's time consuming. It does require training to figure out how a tech piece like this works, just because it's generally more complicated. Layer sizes can be incrementally small as 20 microns per layer. And that is really, really helpful for creating solid parts that are small. So precision tooling fabrication, anywhere from nuts and bolts and screws, all the way up to some medium scale infrastructure. But I would generally say SLM printing is really good for small, fine pieces because of the time consumption, whereas extrusion printing is really good for medium or larger scale infrastructure because it can be scaled up according to the relative use case. So that's kind of the deep tech description between the two types of 3D printing that we'll be going over today. Now
That's
to kind of
small and large. Just what do you give an example of what is small and what is large when you're talking about parts?
Yeah, absolutely. I would say anything that is like tool sized or smaller would be considered a small piece. So anywhere from a socket wrench down to, like I was mentioning, like nuts and bolts, O-rings, fasteners. Something interesting we're working on at Space Copy right now is using the SLM process to take spun regolith that we've turned into fibers and mixing them with wool to create a radiation resistant and moisture wicking textile that can go into the insulation of spacesuits.
Wow.
Yeah, you can do all sorts of stuff with 3D printing, and it's process specific. You wouldn't be able to do that with extrusion, but at the same time, you wouldn't want to start making bricks with the SLM process because that would take you hours upon hours to build something up with a tiny laser. Whereas, extrusion printing, it's like a nozzle, you can build rapid parts. So it's really diverse.
Okay, thank you. That's helpful.
Thank you. Yeah. So turning that kind of adjacent over to what is in-space manufacturing. So ISM, or in-space manufacturing, is the practice of doing exactly what I just described: mission critical supplies, infrastructure, medicine, robotics pieces, supporting both autonomous and astronaut missions on orbit. And on planetary surfaces outside of Earth. So everything from LEO to cislunar space to the lunar surface, you can apply 3D printing in any ecosystem. And the most sustainable and scientifically compelling form of ISM, in my very biased opinion, is in situ resource utilization, or ISRU, which is using any kind of valuable commodities from space as raw manufacturing feedstock. So that's anything from scrap metal pieces that are space debris from dead satellites floating around in orbit. You can take that and use it as scrap material for 3D printing. Or you can take the lunar regolith or the Martian regolith off the actual surface of the planetary body, and you can filter it, process it, break it down into something that's more like a sand sized particulate, because of course you can run into pebble and rock size regoliths. You can break that down, turn it into almost a sand-like material, and then use it either on its own, or you can combine a small amount of binding agent like a plastic or a liquid to be able to do 3D printing. Again, it all depends on your context, but these are the types of in-space manufacturing that have been best proven to work. Um, In-space manufacturing has been done before. It was done for the first time in 2013 on the International Space Station by a company called Made in Space, which is now owned by Redwire. But it's also been validated in different ways. There was a type of SLM variant that was validated by the European Space Agency just last year. So it is fantastic to see that 3D printing in space is not just something that we talk about, but it's something that we actually do. And I know for us at Space Copy, we are kind of still at that TRL 4 stage of development. So we've built out some hardware, but we haven't gotten it to space yet. And we would like to get something launched within the next 5 years to the lunar surface. So we have a really, really big pathway ahead of us when we're talking about ambitious projects like this. Now, speaking of ambition, I think people are wondering, as fantastic as it is to have this great science and promote the space economy, what does that have to do with everyday life here on Earth, and how can that benefit people now that are living in maybe like underprivileged communities or in places where you don't have access to standardized infrastructure? As great as it is to spend billions of dollars on space, how does that help us every single day? And the answer kind of lies in the economics of it. So the space economy right now is valued at 464 billion US dollars. That is going to increase to over the $1 trillion mark within the next 15 years. Lunar manufacturing specifically is slated to increase to $7.5 billion per annum within the next 5 years. So we are on the cusp of these technologies. We haven't sent them out, but there's already a strong market indication that people are looking to invest in this technology. And the lunar economy is recognized globally as the most fast-paced, growth-induced economic market since the dot-com bubble. And if you're wondering why, it's because there's certain processes, certain medical procedures, certain pharmaceutical development, certain material science that just occurs better outside of Earth's gravity. So being able to characterize that, I think it's important to remember that if we're talking about the space economy, we're contributing to a science that allows us to unlock the potential of doing things smarter and better in a more harsh environment, that we can bring that knowledge and that technology back down to Earth and make life easier for everyday people. So I'll leave these metrics with everybody to think about in the back of their brain as we go back into more of a technical setting. So if I haven't made it clear already, I love 3D printing in space. I'm going to talk about it as long as I possibly can. Hopefully, I'm capturing your interest at the same time, but I would also love to share a couple of minutes about what we're doing at Space Copy specifically around this domain. So I founded Space Copy as a small business, completely woman-owned, 3 years ago. That was in the cusp of being part of NASA. I was with NASA just as the Artemis program was being launched in the first place. So I got to see firsthand what kind of technology pieces needed to go into living and working in space, and whether it was NASA's Planetary Decadal Survey or the DoD additive manufacturing strategy. I kept seeing all these indicators from the United States that said we need 3D printing and it needs to go to space, because how else are we going to keep astronauts alive? We can't keep sending up rocket payloads because payloads can fail. Payloads are expensive and they're heavy. And we need sustainable technology. And it wasn't just coming from the United States. The more I researched the topic, it was coming from general North America, it was coming from Europe, it was coming from Asia, the MENA region, the Middle East. Everybody was talking about smart manufacturing, and that has only amplified its voice in the last few years. So what we did is we founded Space Copy. We talk about it as in situ logistics and additive manufacturing. I like to say that's a bunch of fancy words for we build 3D printers that are ruggedized enough to work in the most extreme environments on Earth and space. So talking about Earth and talking about space, ironically kind of cultivate together as being one uniform ecosystem. Obviously, for space, we're targeting the moon as a landing site in the next 5 years, but we can also work in microgravity, so everywhere from LEO to cislunar, and eventually Mars. But more readily so, we're deploying the technology starting in 2026, so right around the corner, in some more extreme Earth environments, not only to test what the conditions of living and working in space will be, but also to provide infrastructure to underprivileged communities. So places like the Arctic desert ocean floor, indigenous communities, areas that have been affected by war or areas that have been affected by natural disasters. We're deploying 3D printers that can take local resources off the ground, like soil, sand, and scrap metal, and turn that into reusable infrastructure from housing, and roadways and tools and pipes and anything that breaks down that's critical infrastructure that you can't really get sent in. So that is the ultimate goal. Now I'm going to turn it over to the audience to play a guessing game with me. This is such a interesting question because depending on whether you follow NASA data or industry data, your answers are going to be relatively different. I'm going to say that this is a NASA data question. So, how much, according to NASA, does it cost to set 1 kilogram of supplies from Earth to the surface of the moon? Does anybody want to siphon a guess? You can put it in the chat or you can come off mute and take your best guess. 1 kilogram. And if you don't know, it's okay. I will tell you. All right. The cost, according to NASA, as of 2025 is 1.2 million US dollars per kilo. Um, Astrobotic says that it's only 445,000, and Elon says it's only 10,000, but NASA currently predicts it to be 1.2 million per kilo. Now, keep this number in mind. It's going to come back to be very important. Sending astronauts to space for long duration space missions is, I mean, intense at best. It requires 22,000 kilograms of supplies to keep 4 astronauts alive in space for a year. At 1.2 million per kilo times about 22,000 kilos, that's $6 billion worth of infrastructure that you're sending from Earth to space. That's crazy just to think about, but actually carrying out a mission like that is multifaceted and highly risky. So, all of that in mind, take 3D printing and remove 70% of that cost overnight. That's the power of doing additive manufacturing and in-space manufacturing. And that's kind of the revolution that we're trying to create at Space Copy, is converting the local materials into usable infrastructure. And we do that through a four-stage process. I'm going to skip ahead away from this use case and skip away from the terrestrial use case as well, because I'm going to show a bigger list of what we can create in just a moment. But if you were questioning why we use regolith in the first place, it's because of that infrastructure and cost savings. And in order to even think about doing that right now, we have to use Simulant in our research and development to be able to communicate, what are we doing? Are we building these systems effectively? And are we ready to go to the moon? So right now, what we're doing is we're working in the laboratory and we're getting ready to send these 3D printers to places like the Arctic. And we're working with regolith Simulant to be able to understand, what are we supposed to expect when we get to the moon. So we actually use our own special custom simulants. There are tons that are out there already, but we work with a laboratory in the US that helps us calibrate some data that was taken from things like Chang'e 5, the rover mission from China back about, I want to say 5 or 6 years ago now, that scanned some of the Artemis landing sites. Because we've never done a South Pole mission, the best that we had for data was around, I'd say Apollo 16, for what we expected to find. And the soil that was recovered during that mission, it was great, but it's not the South Pole. So what we did is we took Apollo 16 data and we took Chang'e 5 data, we combined them together, we created our own custom Regulus simulant, and that's what we're using for 3D printing right now. What are we trying to do with that 3D printing? We're trying to do two things. We're trying to do infrastructure and we're trying to do supply chain management. So the larger pieces that would be created through the FDM printing or the extrusion would be things like launch pad tiles that interlock with each other. It could be also applied to roadways. And then large things like piping that interlock. Blast shields, berms, trusses. There's all sorts of different things that you can create. And then from the SLM side, the more specific, finer pieces, repair parts, simple tools, and bricks for habitats. I'll actually revise that. I'll say we're going to do that with the extrusion printing just because of how long it takes with the laser process. But this is what we're trying to do. And this is how the technology process works. So I said 4 stages. Here we're coming back to 4 stages. For us, the first stage, process that material. So we can't work with just raw moon rocks by themselves. We have to break them down, turn them into a sand-like particulate. That involves crushing and mixing and sieving. Once we've gotten to a particle that we're happy with, we move on to phase two, which we call feedstock sampling. It's basically taking a laser source and scanning it, and that will output some data that we interpret through some custom AI agents that we've built, goes into our software, and it tells you the full mineral profile of what you're looking at. And once you understand what the regolith or the sand or the scrap metal, what it's composed of, is it more aluminum based? If it's regolith, is it silicon dioxide based? How much quartz is there? These all impact the 3D printing method. So you have to be able to understand what your process parameters are. We take that data, plug it into the 3D printer. It'll tell you how warm it needs to be, if it needs to be certainly spaced out in any kind of context to work with that material, any kind of processing that needs to be done further before we can start 3D printing. And then we move into the stage three, the fun part, the actual 3D printing. So again, FDM printing and SLM printing. Last but not least, AI and autonomy. For anybody that's interested in robotics, we have a 7 degree of freedom, fully autonomous robotic arm. It's located right smack dab in the middle of the 3D printer. You might be able to see a little bit my virtual background, maybe not quite. We have that robotic arm responsible for carrying out post-processing, quality assurance, if there's voids or cracks in the 3D printed part, it's able to identify that. It's also able to saw away any kind of imperfections or support structures that were used to build the part in the first place. I'm going to skip over this slide, but for anybody that's interested, you can feel free to take a screenshot. This is just a bit of a difference between SLM and FDM technology. I already talked about some of the difference kind of in my original foreword, that SLM is more geared towards finer pieces and FDM is geared towards larger pieces. SLM requires more maintenance and is costly, and FDM requires almost no training and can be readily deployed pretty much anywhere. But what do we actually create in space? I talked about a good chunk of it already. So everything from space textiles for astronaut suits to tools and housing and roadways, launch pads. But we also do a couple of the finer pieces, about 250 items to date that we have built models of and that we're trying to actively 3D print. Things that you might not think of. So things like turbine blades or scaffolding or fasteners. Door hinges weirdly seem to be the thing that keeps breaking down on analog astronaut test bases. So we're 3D printing door hinges and all sorts of different things. If I were to capture in your mind before we kind of step away from the core part of 3D printing, why we want to do this, I want you to keep four things in mind: speed, ease of use, flexibility, and cost savings. These are the four buzzwords that we keep coming back to when we talk about space missions in general, and they're also the four buzzwords that come into effect when you're talking about 3D printing in space and all the tech that goes into that. So speaking of cool tech, if you wanted to see what we're working on, here is an up close preview. So around that TRL4, so validating it in the lab, but not quite ready to go to space yet. We have 3D printers. We use both off-the-shelf ones, and we're building our own. And we're using regolith simulant, volcanic soil, and Arctic rock to 3D print mostly basic things. So cylinders and tiles and bricks. We're starting to move into tools. But this is a quick preview of some of the things that we've printed in the past. And we're thrilled. Everything turned out pretty darn good, considering that we were just in the early phases of R&D. We have this kind of threshold for achieving a minimum of 74% density on everything that we 3D print. So you can throw it up against a wall and it's not going to break on you. So this was a great validation of what we did. If you want to see it up close a little bit more, that brick on the right-hand side is created with FDM printing. So it is 75% lunar regolith, and it is 25% recycled food packets from the International Space Station. And those food packets were used as a binding agent, helped tie everything together, and it also just really brought home the message of sustainability and recycling. Now, from the far left-hand side, the top picture is a brick that was done with the SLM process, just a tiny little tile. We did some microscopic scanning with our partners at Johns Hopkins University. It came back fantastic, no kind of defects, really good strength. Now we're plugging it into this massive scary machine that you see in the bottom left-hand corner, and that is a two-stage light gas gun And not to scare you guys with technical terms, but what we're doing there is a full micrometeorite simulation test. So it works under vacuum. We're going to shoot tiny little rocks at our 3D printed bricks and simulate a meteor shower and see if they withstand themselves in that kind of environment. So those bricks will be subjected to little tiny rocks traveling at 7 kilometers per second. And that is the next phase of testing that we have lined up for around end of this year, starting into next year. And then last piece of R&D that I'll show you guys is the actual crushing of the lunar soil itself as we're preparing to 3D print with it. So this shows a visual of small pebbles being turned into a sand-like dust over the course of 3 minutes. It's being mixed at super high speeds in this kind of ball milling process. And then on the far right-hand side, you can see the microscopic view of those particles being broken down. So regolith is angular, it's sharp, it's hard to work with. It's our goal to be able to break it down as much as humanly possible before we start 3D printing so that it's not ultimately degrading and wearing and tearing on our systems. We can 3D print for longer. Speaking of 3D printers, this is what we're building right now. This is the actual prototype that's up here in Canada. And this year is just focused on building out this tech. And next year is getting out into the field and getting it to the Arctic, getting to indigenous communities and providing infrastructure, getting to an astronaut analog test base like this one, the F Mars base at the Houghton Impact Crater in the Canadian Arctic Circle. The F Mars base is part of the Mars Society. It's located in Canada's largest asteroid crater. The Houghton Impact Crater is 20 kilometers in diameter and 1.7 kilometers deep. And some of the Arctic rock that's still there bears some asteroid minerals still attached to it. So it's going to be really interesting to get out to the field and print them those door hinges that seem to be peskily breaking down. So that's a quick preview. Again, the tech, what we're doing, where we're going. I think it's super cool. Again, I'm terribly biased. I want to shift gears and spend the rest of my time talking to all of you about why early career professionals and especially young women and girls are suited for careers in STEM and space technology. And every time I talk to youth, and some might even consider me to still be in that category, every time I talk to them, every time I connect to them, I get these kind of four keywords in the back of my brain. I decide to write it down. Resilience, resourcefulness, adaptability, and advocacy for change. So the traditional space industry has been very pale and very male. We've kind of turned this around a little bit, and I see a lot more diversity that's coming into effect. I'm especially proud of people from diverse communities that are trying to fight for that equality and inclusion. But youth in particular, Gen Z, even some of the millennials, even some of the Gen Alpha that are really starting to just understand what space science is. I did a talk last week for kids as young as 6 years old that wanted to know about robotics and 3D printing for space. And I was just enamored because these young people have a resilience in navigating challenges and asking the deeper questions. Youth today, I'm seeing them navigate things like imposter syndrome and academic pressure and trying to balance work and life demands as they're trying to figure out what their career paths are. And they're doing so in such a graceful manner. They are leveraging as many resources as they can. They are not shy, they are bold. They're looking for resources and communities and mentor networks to seek this guidance and share experiences and find solutions. And they are rapidly adapting to new technologies and evolving industry landscapes. They want to learn new skills. They want to not just specialize in one part of engineering, but they want to learn everything. And most importantly, they advocate for really supportive ecosystems so that nobody feels left out in this process. That is my general takeaway from what I've seen from today's generation. And we need that in science because science is all about innovation and creating new and dynamic things. And we need to be doing that in equal parts with the science community. Now, for the power of women in STEM, which is one of my favorite topics of conversation, right now women in STEM comprise 18% of the STEM workforce globally. That is not a huge number. That is 1 in 6 scientists that are female. And I say scientist is a broad term. You don't have to have a science degree. You can be coming from a business degree or a law degree or a marketing or any kind of background. But as far as you're concerned, if you're working in STEM and you're female, you're only 1 in 6. And the increase in participation has been quite global. 10 years ago, that was barely even 10%. Now it's 18%. Another 10 years from now, hopefully we've gone up at least 50% in that metric and have something more like, 25% women. That would be fantastic to see. But the STEM workforce is becoming more open. Science and technology are shaping every aspect of our lives, and we need to fight for that advocacy because when women and girls become excluded from participating in science, we're ignoring half of the solutions that are out there. We're not only ignoring great ideas, but there's things like medicine, specifically space medicine. If you're testing all these different theories, women have different reactions to different processes. We have both a psychological and a physical medical impact on the way that we're shaping how different things operate. We're also contributing a lot of brain power, and we need to be able to recognize that opinion needs to be taken into account if we're going to have a uniform and well-balanced approach to how we work and live in space and how we work and live in everyday life here on Earth. Um, to do so, we need to continue to inspire young women and girls to step into empowering roles in science. We need to make it clear that, this is not an industry that you have to steer away from. There is a place for you here. It's not meant to be easy, it never was, but it is a place that you can find a home in. And the only way that we can do that is by fueling the workforce, providing opportunities, providing growth, education, sitting down and having discussions like this. And then just getting more awareness out there to have more high-paying, high-impact jobs and close kind of opportunity gaps, lift up communities. We don't just want women from one community either. We want them globally. Something that we've done at Space Copy is we have an internship program that is international. So we've had students, female students from Kenya and Uganda, come in and get science training from our team about how to do 3D printing in extreme Earth and space environments. And then they've gone back to their communities and utilize that knowledge and that resource to empower themselves. Now, some of them are pursuing master's degrees. Some of them got into places like International Space University. Some of them are now working for top tier companies within their own country. So I think it's about lifting up people from a global sense, not just one community and not just women in STEM, but everybody that wants to be in science, but particularly shedding a little bit of spotlight on young women and girls and saying, hey, there is a place, and we're going to help you build that momentum. Now, on a final note of that momentum, I want to communicate that there is not just one type of science that you can do to be in space. There are so many different types of aerospace careers. I'm a great example of that. Again, I didn't pursue an engineering degree yet. Maybe I'll get ambitious. But I pursued a business background and then transferred that over to deep tech and just learned a lot of skills and took a lot of courses along the way to try and figure out how space resources work. So you can have careers in engineering. You can go into mechanical, aerospace, chemical engineering, manufacturing engineering, systems, all sorts of different subdisciplines, but you can also be a computer scientist that works on things like digital twins and machine learning. You can be an analog astronaut or an actual astronaut is the probably most common type of space career that people think about. You can be a doctor, both medical or PhD. You could be a physicist, a mathematician, a chemist. You could be in any kind of applied sciences, or you can choose to go more of the administrative route and work in economics, venture capital, law, policy making, marketing. Policy making, especially, is something that I feel doesn't get enough limelight, and we're trying to figure out how we're sending tech to space in the first place. We need more people in these types of careers that are more diverse. Last thing I want to mention is if you don't want to pursue the full, PhD, master's degree cycles, there's still a place for you in space. I've seen a lot of people that came from backgrounds in the trades, electricians, welders, that were getting careers in space. These are things that you can do. You don't have to commit yourself to one specific discipline, and you don't necessarily have to work in one domain forever. Space is diverse, and so are career options, and that is a message that I want to send to everybody. If you're curious, you want to do more outreach besides just talking to me, here are a few good networks for you guys to screenshot that have to do with in situ resource utilization. So these are things that are very moon focused. These are located within Canada and the United States specifically, but they are global networks and they welcome people from all over the world to participate. So the NASA Lunar Surface Innovation Consortium that works in part with Johns Hopkins University, fantastic bunch of scientists and doctors sitting around in a room with students trying to figure out how we send solar panels to space and how we send rovers to space. Everybody from Blue Origin to Lockheed to Intuitive Machines comes in and gives regular talks. They do 2 in-person conferences per year and 4 online conferences per month. So there's a huge amount of opportunity to dive into different subject matters. They teach all sorts of different things. Logic is kind of like a sub-variant. The Lunar Operating Guide, Guidelines for Infrastructure Consortium. I can never get that one right. I purposely had made sure that it was written on the logo before I said it. That one in particular is a little bit more defense focused, but equally part space focused. Talks a little bit more about space policy and then integrates some of the core tech pieces that you would find in the Lunar Surface Innovation Consortium. And they're kind of like sister organizations. They're run by a lot of the same people. Canadian Space Foundation, awesome network, based in Saskatchewan, which is, if you're not familiar with Canada, the middle of nowhere, and run by some of the most brilliant rocket scientists that are actually just sending up random rockets in the middle of the cornfields. Really great network, people that are inspiring change within Canada and Canada. We have a good space community, but I always say that we could be doing a lot more, and these are people that are trying to help us do more. Space Resources Roundtable, another good technical community. They host a conference every June out of Colorado to talk about deep tech and space tech specifically for the moon. The Moon Village Association is a little bit more international. It's owned by a bunch of Italians, as far as I remember, but it works globally, and they have people across Europe and across North America and across the Middle East and Africa, and great representation. They work with the United Nations. They work with a whole bunch of different companies, so there's equal parts tech and equal parts policy going on. And then last but not least, if you want to focus on the policy and business side of things, I am a member of the Interplanetary Chamber of Commerce, which is run out of Toronto, Canada. But they have people in Washington, D.C. and all over the world, even South Africa, talking about how to make space business happen and what we need to do from more of a kind of policy and business perspective to get more small businesses talking about space and working together and forming consortiums and alliances so that they can work together and then intake students and young career professionals into that conversation and just have little bits more of diversity throughout. So those are 6 great resources. I encourage you to check them out if you're curious. The last thing that I will talk about is how to get involved with Space Copy because we have those opportunities, again, especially for young women in STEM. We offer remote international internship programs for early STEM professionals, so it doesn't matter where you're located. We offer kind of a hands-on digital learning experience twice a year. So from January to April with our winter cohort and from June to September with our summer cohort. We currently have 50 students from around the world participating in our summer program and they come from a variety of different backgrounds. We have specializations with accredited certificates, so you can apply it towards an education like university co-op, and you can specialize in engineering, you can specialize in ISRU or physics or computer science or public policy, finance, graphic design, geology. We offer all these different specializations, and you could work in all of these different domains to help us power 3D printing in space. We offer as much outreach as possible, so we work alongside subject matter experts from NASA and other government and academic institutes. So we offer those opportunities for students to meet with them, grow their networks, solve dual use technology problems, and it's really great work experience. And then on the private side, if you're a small business owner or you're more mature in your career and you want to talk about things like consulting or collaboration or joint research, we also offer projects like that, and we always encourage folks to reach out. Um, we're undertaking a huge, massive, multidisciplinary research effort in Eastern Canada right now for 3D printing with some of Canada's most prestigious universities. And we're bringing in PhD students and master's degree students, and even a couple undergrads from across the country, flying them down to these universities, getting our custom lunar regolith simulant out there and doing 3D printing. We're actually actively doing that this week. So it's happening in live time. So these collaboration opportunities, they happen constantly. Always encourage people to reach out because the future initiatives of space and STEM are focused on building community through research, through fundraising, through field testing, and through educational workshops like this. And speaking of education, on a closing note, we are launching our first education course at Space Copy to talk about the basics of 3D printing, a more expanded version of what I talked about today. And that will be launching next year. So if you're curious, go to the website, spacecopy.com. We have a newsletter you can sign up for. And when that course gets close to dropping, you can reserve a seat to be part of it. I will leave on this note. STEM is built on the foundation of collaboration. By fostering innovation and breaking down barriers, we are setting the precedent for our global future. We couldn't do this without a community, and I'm really glad to be here talking to this community today. So, if you want to participate, we have a quiz for anybody that wanted to engage with us further. You can scan the QR code. There are prizes to be had. The first place prize goes to any young early career professional that wants to come and work with us. It's a guaranteed spot in our next internship cohort. Second place is a special invitation to present virtually for our next virtual conference. We're planning some events into September and October to talk about ISRU and STEM and living and working in space. So if you want to share any research that you're doing on the subject matter, you can also apply to win for that by scanning that QR code and completing the quiz. All of the questions should be things that I talked about today, so it shouldn't be too much in the dark. If there's something that you're not sure of, you can either go to the website or take your best guess. And then third and final place is one-to-one mentor office hours sessions with the Space Copy team. So I do mentor office hours all the time, but if you want to sit down, talk with us in particular about anything that you're working on, happy to offer that. So email us at info@spacecopy.com or scan that QR code. We will send you the quiz and really happy to be able to engage with all of you today. So thank you for coming out and listening. If you have questions, go for it. Otherwise, contact us anytime. Always happy to spark a great conversation about space.
Wow, I feel like applauding. That was so good. Um,
Thank you, ladies.
Unbelievable. From no, from the technical point of view and learning about 3D printing, so much exciting stuff. But I also from the community outreach point of view. I mean, wow, you are doing so much yourself, and at Space Copy, you are putting, your words into action and and actually doing it, and not just saying nice stuff, but creating opportunities to yeah, to actually build the community and especially within women in STEM. So it's so inspiring to just hear this, and I'm so excited that you were just able to do this for us. I
Cheers.
just want to say like yay. We do have some questions from girls already who have sent in into our Cosmic Forum some questions. So I want to start off with that. So first of all, I mean,
Maybe there's
totally.
one.
Oh, oh,
Do we can start there and then, or would you rather start with the other questions that we got from the forum?
I'm sorry, I didn't hear what you initially said.
Oh, that there's a question in the chat. So maybe we can get that one first and then
Okay.
the other questions that we got from.
Okay.
Yeah,
Right.
sorry. I was just gonna.
I didn't see the chat one. Go ahead and do the chat one.
Yeah, it first comes with a comment from Isabel. It says, "Thank you very much for this amazing webinar. It was really inspirational and full of opportunity for us girls in STEM." And then her question is the internship opportunity available for girls in high school? And again, she thanks you very much for everything.
Isabel, you're incredibly kind. Thank you for taking the time to come here and listen today. And the answer is yes. Our youngest students are 16, and we try to promote this opportunity for high school students, undergrads, and graduate students, as well as early career professionals that are just graduating school. If you're from the younger side, if you're a high school student, absolutely you can participate. There will be a little bit of mandated training to help get you into like the nuances of living and working in space and kind of the more deep tech side of what we're building at Space Copy. Because, I mean, people that are in a PhD level are different from people in a high school level, and we mesh them all together. Everybody works together. But absolutely, we open up our applications that anybody who is 16 years or over can participate.
Excellent. So the
Great.
first
Thank
question,
you very much.
yeah,
Thank you.
yeah. It's really funny that the first question that we got from the audience was, how does it feel to be such a cool role model working in the space industry?
I am flattered by that. Thank you. I try to give people the opportunities that I didn't have when I first started my career. So I got lucky that I got to go through things like the Science Art Exchange and the director of that program was a woman in space who used to run NASA Johnson. And she gave me an opportunity to have my voice heard, even though I ended up being disqualified for the competition for being too young. She encouraged me to send my ideas to NASA, which eventually landed me getting a part-time job there at a really young age. And I wouldn't have been able to even be passionate enough to do that without a supportive network. And that came from women in science that I looked up to, that came from my teachers, who were all women, that came from my mother, who homeschooled me through a couple of years of my formative life. So having a support network, I think, is a priority. And if I can provide at least a little bit of support or guidance to people that are stepping into science careers, I think that would be the ultimate reward.
Super cool. Okay. Next question. Where do you get your funding for all of your amazing projects?
Well, we're currently fundraising right now. Aside from that, though, like friends and family and bootstrapping got us initially off the ground. We raised $200,000 through grant programs and business accelerators, and family and friends. And then my savings was able to kind of get this technology off the ground. But now we're actively doing some investment and private equity fundraising, trying to get $5 million in the bank within the next 12 months. We've got some leads. About 1.7 of that, I believe, is committed, but still looking for a lead investor. This is a very averse climate to be working in right now, and people need to see that technology is being validated before they invest their capital into projects. So what we're doing is we're trying to get little bits of incremental funding. We have crowdsourcing platforms that are currently active, and we have obviously a huge, huge repertoire of investors that we're talking to just to get the initial tech out of the gate, validate it in like the Arctic environment, like I was showing in the presentation, then continue to raise on more capital.
Right. Okay. Also, audience members, if you want to raise your hand to ask a question now, this is also the time to do that, and we'll call on you. We have another question, which is, how did you first get involved in 3D printing, and what got you into it? What was the spark that moved you in this direction?
So I undertook my first 3D printing project, which was to simulate 3D printed life on Mars in 2017. So that was 8 years ago now. And it was God, was I even in high school at the time? Probably not. A science project for school. And the theme was space sciences, and I was able to work on pretty much whatever project I wanted to. And I got to work on 3D printing for Mars, and that was a subject I chose, and it remained as a dormant project. I did the project for school. I kind of let it slide back. I tried to apply it to NASA. Like I mentioned, I didn't get into the first program, but they apparently they kept my name in a repository because they came back a couple years later with a job offer. And then the NASA Space Apps Challenge cropped up in 2022, and I almost didn't sign up for it. I was this close to not signing up, but the theme was 3D printing on Mars. And so I was like, you know what? We're going to take this old dormant project, we're going to recycle it, we're going to make it bigger and better. And I ended up working with a great international team, and they told me, we've heard of this business program in Saudi Arabia that's talking about space infrastructure. You should apply to it. I did. I got in, I went out to the Middle East and did a business acceleration program, came back here and said, you know what? I've worked at NASA and seen that they want this tech. And we went through this business program. Clearly, it's viable if we craft it properly. And so that's what we started to do. And that was 3 years ago. And it has grown exponentially. I could not have predicted that it was going to be the success that it is today. And I continue to be grateful for everything that we do every day.
Unbelievable. Okay, next question. So let's see. What's been the biggest challenge when trying to use 3D printing to build things like tools or structures on the moon, and how close are we to making it actually possible? I think we are doing it, right?
We're doing it in microgravity. So European Space Agency and Maiden Space have already proven it on the ISS. We've had, I think, a couple attempts at landing 3D printers on the lunar surface. No huge demonstrations, but some very like basic laser systems that were attached to other payloads that unfortunately didn't make it to the surface. So we haven't been able to validate it on the moon yet. Well, that gives us an opportunity to be the first people to do so. So that's the kind of 5-year goal with Space Copy. But it's actively being done in space, and we are doing it in the lab environment and getting ready to take it out into the analog astronaut environment. So we have a pretty good fundamental understanding that it works. People have done 3D printing with regolith under vacuum conditions already. So that's pretty much as close as we can get for now. And in the next couple of years, we're really going to start seeing that market shape up.
All right, cool. Carla, would you like to ask some questions as well?
Yeah, I wanted to ask, how is it like working in a space startup?
It's challenging in a fantastic way. When you're talking about space in general, it's not 100% a stable ecosystem. So there's things that are radically changing, which I kind of
Mm,
appreciate. But it also means that you have to be highly adaptable and you have to be ready for change, especially with a startup. You're lean, you're scrappy, you're working with things that constantly change, and you don't have a lot of
mm,
funding or flexibility to work in that domain. You kind of have to just go with the flow and try to do the best that you possibly can to do incremental things to build a bigger business. Amongst the Boeings and the Lockheeds out there, it's challenging, but I wouldn't be in this industry unless I loved a challenge, and I honestly can't see myself doing anything else than space-based entrepreneurship.
mm.
Oh, I see we
That's
have
really, really
a
cool.
question here in the chat from Samira. She says, "Hi, Madison. It was really great listening to you. I have a question. How do you keep yourself paced at tough times?"
Ooh, that's a good question. It's not easy. I'm going to give you the linear answer that I should follow even more closely than I already do, which is try to balance your work and your life a little bit. Don't stray away from hobbies. I owned a jewelry company before I got into science that I was doing mostly as a hobby, and now I still kind of do it as a hobby. And just keeping up with things that you're passionate about outside of work, I think is super important. Um, Aside from this, having good people in your network to talk to. And this is part of what I try to talk about when I talk about community building and mentorship. I have a few people in my circle that I often talk to about challenges of running the business day to day. And I have friends and confidants and an incredible team as well that have helped shape the narrative. And it is not easy by any means. There are days when you don't want to do it. But you think about the broader mission of what you're building, and when people become inspired in general, it's a good indicator that you're on the right track. And for me, I always try to keep that in my mind's eye during those difficult times, and remember that there's always something that's going to happen that's fantastic, and it's right around the corner. And that has been the prophecy for Space Copy since the start, is every time something great happens to us, we never saw it coming. So I'm going to continue to work on that mindset, and I encourage everybody to think the same way, is that something fantastic is just on the cusp and it's coming to you.
That's a really good mindset to have for sure. Because you never know. You think, oh, it's not going well, and then all of a sudden, boom, something happens, and you're in it. I see. Buzra has her hand raised. Would you like to ask a question? Let me see. I might have.
Indeed. If I may, thank
Hey,
you, Minnie,
yeah.
and thank you so much, Madison, for this incredible a session of inspirational experiences and insights. My question is, I've been working the past few months as an arts and technology coach in STEM, like to encourage young kids, like to get them think about space related themes, but also SDGs, so what you're actually now talking about, like encouraging younger generations, a space copy, how do you reach outside of America? Like, I'm based in Europe, so I'm curious, like, do you have any plans like to collaboration? I know ESA has like ESA Kids like program
Yep.
competition. Can you maybe touch on that side? And while I was listening, I had like just an idea like you had in high school. Do you also collaborate in your partnerships like with Airbus? Airbus is like big on aerospace industry, with 3D printing. Like, how is the opportunities that you have like with such big companies, like 3D like printing, laboratory experimenting, like I'm just curious, like, have you ever had the opportunity to like do the tech laboratory experiments with space copy in an airplane, or like, like something in air? Like, I was just curious. Like, thank you so much. Two
Of
questions.
course. That's awesome. I'm going to make those my last two questions of the day. And I'm just really glad that you asked them. I have not been able to validate our tech in a parabolic flight or any kind of air mission. We did a presentation this past weekend for International Moon Day with another Canadian university that's doing so, and we're hoping to open up an area of collaboration with them because that would be another great kind of, I don't know if you can call it an analog test, but a good prerequisite anyways to getting past the Kármán line. So that's that. Um, do we collaborate with Airbus Ventures? One of the former vice presidents of Airbus in Europe is one of our close mentors and friends. So we don't directly collaborate with them as a company. I think that large organizations are sometimes difficult to work with, but there are individual point people from those organizations that can be really trusted and valuable mentors. And then last but not least, on the European front, we actually have, and we don't talk about this often, two joint ventures in Europe. The first is in France and the second is in Poland. We work with a couple universities and a couple companies out there, things like drone manufacturing to get medical supplies into natural disaster sites, and things like liberating oxygen from regolith to help improve the durability of the 3D printing process, while also supplying life support systems to astronauts. Those are the two projects that we're working on out there. I sometimes find myself in Europe, and if you follow Space Copy, you'll always hear about when that's happening. And we highly encourage people where from around the world, no matter what you're working on or what idea you have, to keep engaged with us because we want the opportunity to be able to meet with you and help you if we can. Thank you so much for your questions.
Oh, fantastic. It's been such an inspiring discussion. I really want to thank you, Madison, for sharing your journey and insights with us today. And thank you to all of you out there for joining. We hope you leave today feeling even more motivated to pursue a career in STEM or space. And just to let you know, if you know other people who might have missed this particular webinar, we will be posting this on our YouTube channel. So don't forget to check out that and our webinars in the summer and with the rest of the summer series. I just wanted to say I saw in your slides, Madison, that there were some things that said confidential. Is it okay to post the video?
We are good to post the video. I should have blacked that out. Thank you for checking, but we are
Okay.
good to go.
Okay, excellent. All right. Well, thank you so much. And see all of you in the next webinar. And have a great
Yes.
summer, everyone.